In today's lesson, we are going to see another design pattern that will be the command pattern. First of all, download the code of the project that we have done so far. I have done some small changes, so you need to download it. So now we are going to do another design pattern that will be the command pattern. And the official Wikipedia definition reads like this. The command pattern is a behavioral design pattern in which an object is used to encapsulate all the information needed to perform an action or trigger an event at a later time. This information includes the method name, the object that owns the method, and values for the method parameters. In words that we can all understand, we send commands to an entity. It can be the player, it can be the NPC, it can be any kind of entity that we want from it to perform certain operation. And the commands will contain all necessary logic to perform the action we want that entity to do. Let's see a very basic example for a command pattern. First of all, the entities who are going to use the commands don't need to know the content of the command. It's the same command, the one that is going to provide all the necessary data and information and logic to perform the action. The entities only will know about the command that they will have a method to run. In this particular case, any entity will know that they have the method execute in any command they receive. So that's why we are declaring first an abstract class like this, because then later when we assign commands to the player, he will know that, okay, I can use this method right here to execute the logic that this command provides. In this particular case, after declaring this abstract class, we can implement just a command. And this one is a very simple one. It's a jump command. What this command will do is to apply a force to the entity that is assigned to in order to do a jump. And that's what happens here. In this case, we are extending the method execute in order to apply some force in the direction up to the avatar. Okay, so in the player side, what will happen is that we will have methods in order to assign commands to the particular entity. In this case, the entity is the player. And also in the update method, we will be able just to execute that command. As you can see, the player doesn't know anything about the contents of the command. They only know that the command will have this method execute, and inside this method execute, the command will perform the action. And inside this command will be everything that is necessary to perform the action. Finally, as you can see, we can assign the commands. In this case, we are assigning the command just when the user press the key space. We assign the command, and the command is assigned, and on the update method, it will execute the command and it will perform the jump. So now that we have seen a little bit of theory, let's go for the practice. And the thing that we are going to do first in the script enemy, what we are going to do is just to create a new state called await instructions, and in this state nothing will happen. It's really similar of what we did with the player. So, and the next thing that we are going to do is just to create a public variable, a boolean called activate wait, that we will use to prevent the enemy to not to change to any other state except to die. Why is that? because we want that once it enters this state of awaiting instructions, we don't want to leave this state, because in this state the enemy is going to receive commands and is going to run them, and we don't want him to leave the state awaiting instructions unless it's about to die. So by default, every time we change the state and we check that this variable is true, then we will keep the state in the state await instructions. So go ahead and do it. So the code should look similar to this. The first thing that we have done is to create a new state for the enemy states, and we have created the skeleton, both in the update and in the change state. The next thing that we have done is to create the public variable member, activate wait, that if it is set to true, we will change in the start to the state await instructions. And in the method change state, in the case that the boolean is activated, we check that if we want to transition to any different state from die and await instructions, if the state is not already on the wait instructions, we should change to the wait instructions state. If that's not the case, if we are already in the await instruction state and we want to change to any other different state from die and await instructions, we should return. So now we are going to create a new enemy where we will be able to apply all these changes. I suggest you to use this particular enemy, because I have not used this enemy so far. So you can use it for this new enemy, and just create the new enemy. Just take another existing prefab, drag it to the scene, unpack it completely, remove all the components of that enemy except the rotate to target script. Well, rename it to the enemy 4, create the prefab, replace the 3D model, create the animation controller data, and place the enemy in the level 0 and test that the default behavior works. So go ahead and do it. So the next step will be to select the enemy that we have created, and we are going to set the property activate wait to true. And what we are going to test is that the enemy stays quiet no matter where the player is, and to test that you can also kill it. Okay, so go to the level 0, and for the enemy we are going to set the property activate wait to true. Apply the changes, remove the level, and test it. And the enemy stays there doing nothing, and you can kill it. Okay, so far so good. What we are going to do now is to create an abstract class called command. We will create a new folder called commands in the scripts, and we will create the script command. This class will have 3 abstract methods. That will be the method execute that will run the logic of the command, the method is finished that will return if the command has completed its objective, and method is blocking that will tell us if this command should prevent of other assigned commands from running. So go ahead and implement this abstract class called command with these 3 methods. Go ahead and do it. And the result should look similar to this. We have created an abstract class called command with 3 abstract methods. What will happen is when we will create commands who inherit from commands, we will have to implement all these 3 functions. And in the side of the entity, the only thing the entity needs to know is that it will always have these 3 methods for any command it could receive. So let's create our first command, and the command that we are going to create will be called command move to. The goal of this command will be to move the entity to a target position. This command will inherit from command, and it will have 3 private variable members. These ones that would be the avatar that the command move is going to be applied, the target position where the command is going to move the avatar, and the speed the command is going to move the avatar to the target position. And the methods that you are going to implement for this class will be a constructor that will receive the previous 3 parameters: avatar, target, and speed. And you are going to implement the abstract methods execute. This method will move the rigid body of the avatar to the target position. The method is finished will return if the avatar has reached the target, and finally you are going to implement the method is blocking, and you are going to just return true. So go ahead and implement this command following the instructions I have just told you. So go ahead and do it. And the result should look similar to this. We have created the script in the folder commands. We have created the three private member variables that we need in order to properly execute the command. In the constructor, we initialize these three variables. And on the methods that we need to override, first of all, we started with the method execute, and what it does is just to get the directional vector to move the avatar to the target, and it applies a movement through the rigid body to move to that position with the directional vector, the speed, and the adjustment of time. For the other abstract methods is finished. We are just checking if the avatar is close to the position below 1, we return true. If not, we return false. And in the case of is blocking, we are returning true. So now we need to assign the command to our enemy. Since the concept of commands is to be able to manage multiple commands, we are interested to create a list of commands that we will process one after the other. So what we are going to do, we are going to create a list of commands in the avatar script. Why in the avatar script? Because we want that this command system could be applied to anyone who inherits from avatar, from the enemies, the player, the NPC. Anyone who inherits from avatar could take advantage of the command functionality. So let's go to the code and let's do these changes. In the avatar script, we are going to create this new protected list of commands. And next we are going to create the method add command. And this method will just add a new command to the list. This method will have just one parameter. That will be the command we want to add to the list, and just implement this method add command. So do it. The result should look similar to this. We are just adding the new command to the list. The next thing that we are going to do is still in the avatar script. We are going to create the method run commands that will run through all the existing commands. Okay, so we are going to implement a for that will go through all the commands running its execute method. So go ahead and do it. And the result should look similar to this. We are just going through all the commands running its execute method. Next thing that we are going to do is remove the command from the list when it's finished. Okay, so go ahead and find out how we can check that the command is finished to remove it from the list. Go ahead and do it. And the result should look similar to this. What we are doing right here is just using the method isFinish that is provided by the command class. And if it's finished, we just remove that item and decrease the counter so we can continue with the next command. The next thing that you are going to do is just to consider that there are some commands that are going to block the execution of later commands. Okay, so we have our function is blocking that is returning true or false, depending if we want that particular command to block the execution of commands that have been added after this one. So go ahead and do it. And the result should look similar to this. What we are doing here is that, okay, the command has not finished. So we check if this is a blocking command. I mean, if it's a blocking command, we just leave the loop. And we can leave the loop using break. Break allow us to break the loop and just leave. So when we are running a command that is blocking, we are just stopping from running commands that are posterior to the current command. So finally, it's the time to create the command and assign it to the enemy that we have previously created. So what we are going to do is that on the level controller script, we are going to create this public member variable that will make a reference to the selected enemy. In our particular case, it will be the enemy that we have just created for the implementation of the commands. So let's go to the level controller and declare a public enemy as selected enemy. Okay, now on the Unity editor, we are going to initialize that variable. Okay, and we are going to initialize it with the enemy we created. Back to the level controller script, on the start method, what we are going to do is to create the command move to with a target position that is close to the enemy. Okay, so first of all, we can go here and we are just to create an sphere right here, maybe. Okay, no, right here. Let's create an sphere. Okay, and let's move the sphere just a little bit right. Okay, right there. But these are local coordinates, and we are interested on a wall space coordinate. So what we are going to do is to place the level into the scene. We are going to unpack completely, and we are going to move what we have created just outside the level. Okay, and we got here the information about the coordinates we need to store. And these are the coordinates that we are going to use for the command move to in order to instruct the enemy 5 to go to that point. Okay, so we can proceed and remove the level from here. We keep the sphere in order for us to see that the enemy is going to move towards that. So with these coordinates, we can continue. And with that information, what we are going to do on the start method is to create the command. So we are going to create the command with the avatar to apply the command. That would be the selected enemy, the target, that is the information we got there. And the speed, we are going to set a speed so it moves slowly to the target. Maybe with a 5 it would be enough. So we have created our command. The next thing that we need to do is just to assign this command to the enemy. Okay, so to assign the command to the enemy, just in the selected enemy, just add command, and you add the command as a parameter. Now back to the script enemy. On the state await instructions, we are going to call the method run commands. Okay, run commands, and if there are commands in this method, they will be run. Okay, if everything has worked, if we go to the Unity editor, let's remove the collider from this sphere and let's play it. So if we check on the enemy, as you can see, the enemy is going towards that position. Okay, so the command is working fine. So the next thing that we are going to do is to improve the command move to. And what we are going to do is to check if the avatar has the component rotate to target in order to use this component to rotate towards the target that the avatar is moving to. So go ahead and do it. And the solution should look similar to this. What we are doing is just to check if the avatar has also the component pattern rotate to target. And if he has it, then we get that component and call the method activate rotation, so the avatar also rotates towards the target. If we proceed to run it and go to check the enemy has rotated towards the target. Okay. The next improvement that we are going to do is just to create the necessary code to change the animation of that particular enemy, the enemy that we have assigned the command, in order for that enemy to change the animation from idle to run or from run to idle. Okay? The first thing that you are going to do is just to create two events in the system event controller that will be these two. Even avatar play animation run and even avatar play animation idle. We are going to dispatch these two events inside the command move to, find the place where you should dispatch them and dispatch them. As an additional parameter, when you are dispatching these two events, you should specify the reference to the avatar. In the script that is going to be listening the events, it will receive the name of the events plus the parameter that will be the reference to that avatar. And we can use that information to compare if the avatar it matches with the current avatar. So we can change the animation there. Okay? So go ahead and do it. First of all, find out where the events should be thrown, then where the events should be listened, and with the extra parameter that you are sending aside the name of the event, compare it in order to verify that it's the right avatar to change the animation. So go ahead and do it. And the code should look similar to this. The first thing that we have done is in the command move to, we are dispatching both events, the animation run and the animation idle. But we are interested to only dispatch them once. That's why we have created this method, that this method will dispatch either if it should play the animation run or it should play the animation idle when there is a change in the state of this command. If this command is telling the avatar, okay, you should run, then this state will change. Okay, if this state is changed from the previous state, we just reset this boolean, telling the system that he needs to dispatch the event to tell the other parts of the system that, okay, the state of the command has changed, so report that the animation run should be played. And finally, we are calling both change running state to false when we are close to the target, and change running state to true when we are far away from the target. So these two events will only be triggered just once. And on the side of the enemy, we are listening to that events and we are retrieving the parameter, the additional parameter, okay? And we are comparing, since the enemy is inheriting from avatar, we are comparing, okay, is the right enemy? If this is the right enemy, then we proceed to change the animation. And we are doing that both for the animation run and the animation idle. So in short, we'll have a system that it's optimized to dispatch only one event when there is a change on the state of the command. And on the side of the enemy, he will listen for the animation changes, check that is the right parameter, and proceed to change the animation. If everything is right and you proceed to run, if we check the enemy, it is running until it reaches the target. Then it transitions to animation idle. Good. In the next part of the lesson, we are going to keep improving our command pattern system. To do it, we are going to create a new singleton called GameController that will manage most of the operations related with the command patterns. So as I was saying, we are going to create a script called GameController, and we will place it in the folder controllers, and you will add the accessor to convert it into a singleton. So let's do it. This commander controller will inherit from state machine. Okay. And back to the editor, we are going to create an empty game object that we will rename GameController, and we will add our script GameController to it. The next thing that we are going to do, we are going to create a static method in the utilities script that we will use to do raycasting against the enemy layer. Okay, in this occasion, I am just going to provide you with the static function, because we have already done something similar in previous lessons. So just copy this code in utilities, add it as another function, and a short summary of what it does. It raycasts from the mouse position, considering only the layers we want to consider. We will need this one in order to be able to select enemies or other elements from the game. Now in the GameController script, in the update method, we are going to use this method that we have included in the utilities script to get a collided enemy when we press with the mouse button. And the result of the game object that we collide with, you are going to print in the book log console the name of this object. So go ahead and do it. And the result should look similar to this. We are checking if the mouse button has been pressed, and if it has been pressed, we recast from the mouse position to check if we are clicking over an enemy. If we are clicking over an enemy, the selected enemy should be different from null, and we are just displaying a log message in the console just with the name of the enemy. Save the progress, go to the Unity editor and press play, switch to the free camera and click on an enemy. For example, this one. Okay. We have missed to disable some functionality, so we are going to do it now. Right now, we are going to disable the previous functionality related to the player. So go to the player and disable for the moment the code with await instruction of the player. Okay. And let's try again. Switch to free camera and select the enemy. Okay. If we select another enemy, okay, that one it works because the new enemy is still not in the layer enemy. So we are going to fix that. We are going to the prefab and we are changing the whole thing to enemy. Now, if we go back to play, switch to this camera and click, now we are getting the right message. The recasting of the mouse against the level gets that I am selecting this enemy. The next two steps that we are going to do in the same command controller are first to create a private member variable where we will keep the selected enemy. And the other change that we are going to do is we are going to create a new text component on our UI that we will fill with the name of the selected enemy. So what you have to do is just to create a public member variable of type text in the command controller and reference that element with the UI element that you have created. And when you select the enemy, just set the previous private member variable and set the text of that previous text field. So go ahead and do it. So the result should look similar to this. We have created that private member variable that will reference to the selected enemy. We have used that variable to keep the information about the collided element. And if we have collided with an element, then we are doing the actions of displaying the name in the debug log console and also displaying the name on the text field. Okay, for the text field, we created this public member variable, and we are setting that public member variable with the new text component that we have created right here. We can set this to empty. Okay, now if we proceed to play, when we select an enemy, the text field should be set to the name of that enemy. Okay, as you can see, enemy 5, and if we select another enemy, enemy 2. Okay, it's working. Now back to the command controller script. We are going to create 4 states. Okay, we are going to define an enum type called state commander that will contain these 4 states: select unit, select action, set data, and assign action. Okay, first create this enum type, then create the skeleton for the change state and the update, covering all the cases. In the start method, you are going to change the state to the state select unit. Okay, and what you are going to do is to move the current logic that we have done about selecting a unit. In this case, we were selecting enemies. So you are going to move all this logic inside the state select unit in the update method. And as a condition to transition from the state select unit to the state select action, just check if we have selected an enemy. If we have selected an enemy, then transition to the state select action. So go ahead and do it. Okay, and the code should look similar to this. First of all, we have defined the enum type, state commander, the 4 states. Next, we have extended the change state. We have created the skeleton, and the same, we have created the skeleton for the update. Finally, we have moved all the logic about selecting an unit into the state select unit. Finally, if we have selected a unit, we change the state to select action. Okay, now on the UI, we are going to create a drop-down. In this drop-down, we will put the commands that we will assign to the different elements of the game. Right now, we are going to assign it to our enemy 5, but eventually we will assign commands to multiple units. Okay, so back to the Unity editor. On UI, you are going to add a drop-down. And this drop-down, you are going to place it close to the text field where you were showing the selected unit. You can rename the drop-down as command options. Just for the sake of testing, just run the editor, switch to the free camera, and check that you can interact with the drop down. Next, back to the command controller script. What we are going to do is create a public member variable on the command controller in order to reference that previous drop down. Okay, so create the reference to the drop down and set the reference in the editor. Okay. Now, what you should do is first, you should initialize this drop down with 4 values. Okay. Are these 4? In order to fill the drop down, just do this search and find the code in order to fill this drop down, and to detect when the drop down value has been changed, do the search and implement a listener that will be triggered when the drop down has been changed. Every time that has been changed, you will display a debug block message just to verify that you have properly detected that the drop down value has been changed. So go ahead and do it. And the result should look similar to this. First of all, we have cleared all previous options that could be in that drop down, and we have added our options. To add the options, we have this method add options that we can provide the list of options as a list of strings. After that, the drop down has a property called onValueChanged, and we have added a listener to that property to listen when there is a change on the selected value for the drop down. When there is a change, this method will be called, and we are just displaying a log message with the index of the selected command. If we go and run the project, change to the free camera, now, and enable the log messages, now we should see that we are changing the value of the combo box, and we are detecting when it has been changed. So now that we are listening to the changes on the drop-down value, we can react to that changes. And what we are going to do back in the command controller script, we are going to first create an enum type with the different commands that we are going to provide in the drop-down. Okay. After that, just create a private member variable using that enum type that will store the selected command. And of course, depending the selection on the drop-down, you will set the previously private member to the right command. Finally, you have to change the state of the whole command controller to the set data state. So go ahead and do it. And the code should look similar to this. We have created first the enum type with the available commands that are in the Dropbox. And next, we have created the private member variable of the type command types. And when we detect the change on the value of the dropdown, we set this variable to the right command. And if the right command is different from none, we transition the state of the command controller to the set data state. If we go to the Unity editor and press play, switch to the free camera, if we change to some state, as you can see, the new message with the final command type has been properly displayed. Before continuing, we are interested in showing the drop-down only in the state action of the command controller. So what you are going to do is to hide this drop-down in any other state that it's not the state action and show it in the state action. So go ahead and do it. And the result should look similar to this. We are just hiding the drop-down for all the states except in the state select action. In the state select action means that we have selected an enemy and this enemy is expecting to have assigned an action. Still in the command controller, let's add another text component to the UI that will show the action selected. So create a text in the UI, create a public variable member that will reference this text in the command controller, and fill the text with the action selected in the dropdown. Show only that text when you are on the state set data. Okay, so go ahead and do it. And the result should look similar to this. We have created a new public member variable of the type TextMessagePro that will make reference to a new text field in the UI, this one. And we are setting the value of this text field just when we transition to set data. In the change state for the set data, we are setting the text of this text field to the selected command. If we proceed to run, first we should select an enemy. So let's go to select an enemy. The Dropbox has appeared, and now we are going to select an action. And as you can see, the text field in the UI has been set to the action to the command move to. We are going to add yet another text field into the UI, and in this case, this text field is going to help the user to tell the user what it should do once he has selected a unit and selected the command he wants to assign to that unit. In this text, we will provide the information for the user to know what he should do to complete the whole assignation of the command to the unit. Okay, so create the public member variable that will make reference to the text field, and fill that text field with the information related to each command. For example, for the command move to, you can tell him you should click the position to go. For the command look at, provide the position to look. And for the command attack, you can tell him select the avatar to attack. Okay, so go ahead and do it. And the solution should look similar to this. We have created another public member variable of type TextMessage Pro. We have created another text field component right here where we will put the description of the action that the user has to do to complete the assignation of the command to the enemy. And in the set state, we are evaluating what action we need to perform to display the right instructions. If we run the project, select a new unity, select move to, we get the name of the command and the action the user should do to complete the assignation. In this case, we should be clicking a destination point, so we can assign a command move to this unit to go to the desired position. So now it's the time to provide the final piece of information to be able to assign the command to the selected unit so the command can be performed. And we are going to provide the necessary data in the state set data. Okay, so what will happen is that in the update method, in the state set data, what you are going to do is just evaluate what type of command the user has selected. And for the command move to, what you are going to do is just to check if the user has clicked with the mouse on the floor, telling the system that he wants the selected unit to go to that specific position. You're going to get the collided position with the floor to get that position, and once you get that position, you will be able to fully create the command move to and assign the action to the unit. Okay, so go ahead and implement the functionality following the instructions I have explained. And the result should look similar to this. On the update, for the case of the state set data, we are evaluating what command type the user has selected. Okay, if the command type is move to, what we are doing is just checking if the user has pressed the mouse button. If it has pressed the mouse button, then we check the collided position, and if the collided position is the right one, we set the target position and we change the state to the state assign action. In the state assign action, we will finally create the whole command and assign it to the selected unit. So finally, with all the necessary data in order to create the command, it's time to assign the command to our selected unit. First, on the method change state, for the state assign action, first you are going to evaluate what type of command the user has selected. For the type of command move to, you are going to create a command move to, for the selected enemy, and you are going to insert that command in the list of commands of the selected enemy. Okay? After doing that, change the state back to select unit and set the selected enemy to null so we can select another one. And also set the drop down value to the value none. So go ahead and do it. And the result should look similar to this. So in the exact moment that we are transitioning to the state assign action, we check the command that the user has selected, and if it's the command move to, we create the command, okay, specifying the parameters of the selected unit with the avatar component, the target position, and the speed. Then for the selected enemy, we get the component avatar and we add the command to the commands of this unit. We set the selected enemy to null because we want to reset the whole thing so we can select another unit again. We also reset the value of the drop down, and also we'll reset both text fields. Finally, we change back to the state select unit so we can start over and select a new unit. So if we proceed to run the project and go through all the process, change to the free camera, select a unit, select the command move to, and click into the position you want to send that unit. And as you can see, the unit is going to that particular position. We can do it again, select it, select the command, and select another target position, and the enemy is moving towards that target position. So we have implemented by this way a commander system where we can select units and assign them commands that will contain the whole logic that this unit should do. And with the implementation of this command controller, we finished with the introduction to the command patterns. And as extra exercises to practice a little bit more about the command patterns, I propose you to do these exercises. The first one is to create the command lookat that will make the selected enemy to look to a target position for a duration of time. The second exercise would be to improve the existing command move to use the navigation if the target position he should go has no clear path. Also to create the command pattern command attack that will attack a selected unit. The unit doesn't need to be the player. You can choose an enemy to attack another enemy, or an NPC, or of course a player. And also you can prepare the code to select multiple units by defining a square area with the mouse. Okay, all these exercises have been completed also in this link, and if you had trouble up to this point to do the lesson, you can also download it right here. But before you start, I want you to make a small change in the camera controller. And in the camera controller, we are going to allow the movement of the free camera only if the user is pressing the key. By forcing the player to press the key left shift in order to be able to both move and rotate the camera, we will be able to have better control when assigning commands to the units. Let's test it right now. Let's run it. We go here, we change, and right now I am trying to move and I cannot. But if I press the shift key, I can move and rotate and select, and I have more control over the whole thing. So you can go ahead and do the exercises. And the implementation of the command look at should look similar to this. What we have first done has been to create the new command, inheriting from command, with these private variable members, the target avatar, the target position to look at, and the time that the avatar is going to look to that particular position. In the constructor, we just initialized the private variable members, And on the execute method, if there is the component rotate to target in the selected avatar, we use that component. If there is not, we just rotate using the look rotation of the quaternion and specifying the parameters to look to that specific position. In the method is finished, we should keep track of the time, and when the time goes above the limit of the time, we should return true. In the command controller, what we have done is just to, in the case of the update, we check where the user has clicked in order to store that position, and finally, when assigning the action, we just create the new command, the command lookat, with the specified avatar, the target position, and the time we are going to look to that particular position, and we assigned that command to the selected avatar. Finally, we reset the state so we can select another unit again. And the improvement for the command move to include the nav mesh agent behavior if there is no clear path to the target position should look like this. What we have done is, first of all, we have added the nav mesh agent to the enemy. Okay. Next, we have gone to the code. We have created a private member variable to make reference to that nav mesh agent. And we are retrieving that nav mesh agent from the avatar. Okay, if it exists, then we disable it, because remember that the collider component and the nav mesh agent component collide, so we need to disable the navigation in order for the collider to work. And we check if there is an obstacle between the target position, okay, and the position of the avatar. For the target position, what we have done is just to get the X and Z coordinates and use the same Y coordinate for both. Okay, so if there is an obstacle, then we will use the pathfinding. We set this boolean to true, deactivate the physics, enable the navigation and set the destination. Okay, in the execute, if we are not using the pathfinding, run the behavior as always. But if we are using the navigation, what we are doing here is just to adjust the model in order to face the velocity vector applied by the navigation. And in the is finished, we have changed the distance by a new method that only will take into consideration the coordinates x and z in order to detect that we have arrived to the destination. If we have arrived to the destination, we disable the navigation, and if we are using the navigation, we are going to restore the initial orientation of the local model. Okay, we are restoring the initial orientation of the local model because on the execute method we have been setting that orientation in order for the unit to face the direction he's moving. Finally, we have activated the physics again, and after that the job is done, and we have performed all the tests that we needed to confirm that it works. The next exercise that I recommend you to do is to create the command attack. Okay, so go ahead and do it. And the result should look similar to this. We have created the command attack. We have created the necessary private member variables in order to follow and attack the target. We have defined the target, a speed to move to the target, a range in which we are going to attack the target and a frequency of the attack. In this command, we are also going to consider that we can use the navigation to navigate to the target if the target it isn't in a clear path. And in the constructor, we initialize the state. And in the execute, there are two main states. The state that we are in attacking range and would proceed to attack with the frequency we have decided. And if we are not in range, we would proceed to check if there is a clear path between the avatar and the target. Then we just update which method we are using to go to that target. So this variable is using pathfinding will be to true or false depending if there is a clear path to that target. If there is no clear path, if we are not using the pathfinding, we go straight to the target. But if there is no clear path to target, we use the navigational component to go there. Okay. Next, we would check the distance from the avatar to the target, and if we are on attacking range, we would change to the easy in attack range, so the enemy could attack. Finally, it's a ending condition. If the target is null, or if the target is lives is below 0, then we will return true, and this command would be deleted from the list of commands. Finally, on the command controller, for set data option, what we have done is, okay, when we are clicking on the scene, we are checking if we are selecting any of these elements as the target that we want to attack. Okay, we have declared this private variable member just to save it to, so after setting this variable, when we are creating the command, we can use the target. So here we are adding the new command attack to the selected enemy in order for the enemy to go and attack it. So the next exercise would be to be able to select multiple enemies or multiple units by drawing in the floor a square area with the mouse. So go ahead and do it. And the code could look similar to this. The first thing that we have done, since now we are going to select multiple units at the same time, has been to convert just the reference to just a single unit into a list. The next thing that we have done is that, okay, now we are supporting two methods of selecting a unit, just by clicking on a single position or creating an area and selecting all the elements that are in that area. For the first case, for selecting with a single ray, we still have this method where we are checking for the player, the enemy, or the NPCs. And in the case that there is collision with one of them, we select them. And for the case of the create an area, what we are doing is we are getting the collided position of the mouse in the floor, and we are creating a plane with that information. When the user releases the mouse button, we finally check if in the area that we have created there are selectable elements, and that's what we are doing in here in check selected avatars. In check selected avatars, what we are doing is checking if they are inside the area that we have drawn, and if they are inside the area that we have drawn, we add them to the list. We are just checking only for the player and the enemies. And for the case of the NPC, since there is no state await instructions, we are not considering as a selectable thing the NPCs. So far, only the player has a state await instructions, and also the enemy has a state await instructions. So only these two elements can be selectable. And that's what we are doing here, checking if the player is selectable and inside the area, and if there are any selectable enemies inside the area. Once we have selected the list of enemies, what we are doing is when we assign the action, we go through all the elements assigning the right command. We go for each element of that list, assigning the command that the user has selected. Okay, this is the end of the lesson about command patterns. As you could have imagined by now, the command pattern could prove useful in real-time strategy games where you have to give a range of commands to multiple units. Their use is not restricted to that games. I worked once on a match 3 game that were using command patterns in order to handle the multiple different combinations that you could do with different types of cells. So the application range of the command pattern could be a good option for multiple scenarios.